Most of the fractions that we deal with are proper fractions. So a proper fraction just has the property that the number upstairs is smaller than the number downstairs. So as an example, in the fraction 1/4, what we're conveying to people is I need 4 equal size pieces to make my one whole, but I only have one of those pieces. So obviously I don't have one whole. So proper fractions are always going to be between a 0 and 1. So I don't have nothing, but I don't quite usually have my one whole. So let's talk about what an improper fraction is. So those ones have a numerator that is larger than the denominator. So as an example, in the fraction 11/5, the upstairs number 11 is bigger than the downstairs number, which is 5. So improper fractions are going to be larger than 1. And we're not going to be working with sign numbers right now, so we can talk about what this all means when we have positives and negatives later. But just for right now, we'll just say that improper fractions, you would have more than your one whole. So then the idea is, how much more do you have? So we'll find that out. We'll go back and forth between an improper fraction and what is called a mixed number. So a mixed number is a number that has an integer plus a proper fraction. So as an example, in the mixed number 1 and 3/4, so we would verbally say this as 1 and 3/4. We normally don't write the plus sign, but it is absolutely there. So another representation for this is 1 plus 3/4. So what we're telling people is that I have one whole and I have 3/4 of another whole. So we suppress writing that plus sign. We kind of smash the two next to each other when we just write it as 1 and 3/4. So let's go back and forth between the two forms. So if we have something that is improper, let's write it in its mixed number form. And if we have a mixed number, let's take it back to an improper fraction form. All right, so for the improper fraction to its mixed form, you're going to do long division. Now, some of these, depending on the division, you might be able to do them in your head, but let's talk about what exactly you're doing. So in the improper fraction 11/5, I would want to, for the long division, put 11 underneath the long division symbol, and 5 would be on the outside. So I'm asking myself, how many times does 5 go into 11? So 5 goes into 11 2 times. 2 times 5 is 10, so I would subtract that off, and I get a remainder of 1. Now earlier, we could write this, as for if I have 11 divided by 5, we could write this as 2R1, right? So 2 would be the quotient, and the remainder is 1. So as opposed to writing it in this R form now, though, we can write this in its mixed number form. And the way that you would pull this off is that this is your quotient, and then 1 is your remainder, and then 5 is still going to be the denominator, because the idea is in the mixed form, my whole is still broken into 5 equal size pieces. So this would be then 2 and 1/5. So I have 2 whole pieces, and then I have 1/5 of another piece. Okay, so you just kind of go from the top, grab the number at the bottom, which is our remainder, and then grab that original divisor. So whatever the denominator was originally will still be the denominator in this mixed form. Now in this one, you might be able to have just done that in your head. So we could ask ourselves for 11/5, how many times does 5 go into 11? It goes in 2 times with 1 left over. But sometimes these get a little bit larger, so then there's where the long division process comes in handy. So 127 over 11. So 127 divided by 11. So first I would ask, does 11 go into 1? No, it does not. Does 11 go into 12? Yes, it does one time. Subtract off the 11, you get a 1. Now I'm going to bring down the 7. Does 11 go into 17? Yes, it does, one time. Subtract off the 11, we get a 6. I have no more numbers to bring down, so I'm done with the long division process. So I would write this in its mixed form as 11 would be the whole part, and then 6/11 would be the fraction part. So the remainder from the process is the numerator in your fraction, And then again, the denominator in the fraction is always whatever the original denominator was. All right, so if you have a improper fraction and you want to write it in its mixed form, we can do long division because we need to figure out what this remainder is. Now, what if we want to go the other way? What if I have something in mixed form and I want to take it to an improper fraction, which is typically used when I want to do operations on fractions. So the way to do that is to do what I call bottom times side plus top all over bottom. So for 2 1/5, I'm going to write this a little bit bigger so you can see what's I'm going to do. To figure out the new numerator in this mixed form, because the denominator again is not going to change. Whatever this original denominator here is going to be the denominator here. So I just need to figure out what the new numerator is. And to figure out the new numerator, you're going to do the bottom number, which is the 5, times the big number, which is on the side, plus the top. So bottom times side plus top. So 5 times 2 is 10. 10 plus 1 is 11. So the number that I want right here would be 11, and then the original denominator. So 2 1/5 is equivalent to 11/5. Now why this is going to work for us is 2 1/5, remember, is 2 plus 1/5. Okay, so I have 2 wholes plus 1/5 of another whole. So this is starting to get into a little bit of fraction addition, but 2 can be thought of as 10/5. So remember, I need 5 pieces to make 1 whole, and I have 2 holes. Okay, so if I only need 5 pieces to make 1 whole, but I've got 2 holes, then I've obviously got 10 pieces. So if I've got 10 pieces over here, and plus 1 more piece from right here, then overall I have 11 pieces, where apparently I only needed 5 pieces to make my 1 whole. Again, that's getting into a little bit of the fraction addition, and the need for common denominators and things like that, but that's roughly what's going on with how we are figuring out these numerators. So just to kind of repeat that process over here on this next example, the 12 3/4. All right, so I'm going to do bottom, which is 4, times the side, which is 12, plus the top, which is 3, and it's going to be all over the original bottom, which is 4. So then upstairs I would have 4 times 12, which is 48, plus 3, which is 51, all over the original denominator, which is 4. So 12 3/4 is equal to 51/4 in its improper form.